Everything that is built is designed by mathematics. In this film, we meet 3 young structural engineers who work for the Walsh Group to find out how important their role is.
When architects have their vision of building up something, they have a plan of what it will look like, but they don't actually know how it would actually be done physically. For them, it's about how good it looks, how it would affect the surrounding area and things like that, and how it's going to work with the entire planning scheme. Whereas like for us, we make their dream come true. This is what I think, because we make it happen by using mathematics. We derive everything from first principles. We're the people, we're the problem solvers.
I'd say the structural engineer, the key thing is that we basically make sure that the building stands up. The structural engineer is responsible for the design of all structural elements. We use maths in every single step along the way. In the initial stages, you're doing primarily the design, so you're working out the sizes, and then from then you'll be marking up drawings to give to technicians to get the drawings built.
If you're building only a 1-story building or 2 stories, then wind is not so much of a factor. But if you go to medium rise to high rise structure, it is one of the most vital thing you have to consider. And in London, the basic wind velocity would be about 22 meters per second. That would translate to about 1 kilonewton per meter square. Imagine 1 meter cube sideways. You chuck a big fat rugby player across that space. That's the wind load you roughly get.
So what we have is core walls that resist the wind loading and makes the building stand upright. So if you imagine in nature you have a tree, when the wind blows on that it doesn't fall over because it's got its roots on the foundations, and the core is a stiff element which keeps it upright. And that's the same thing with the building.
When it comes to building, there's generally 3 things which needs to be brought in mind. That's cost, aesthetics and safety. And it's always a case of trying to get the balance of all 3, because you can make things very cheaply, but it'd be very ugly. You could make things very slender, but it probably wouldn't stand up. The type of maths we use is very wide-ranging, actually. I mean, for example, when you're setting things out on site, it's all about angles, because they have fixed points, and through trigonometry you can work out where things need to be, how tall things are, and all sorts. To do the actual design of the structural elements, or the slabs and the columns as a whole, there's an awful lot of algebra, and it's not as complicated as you may think it is. We do a huge amount by hand, because quite often it's quicker in a lot of cases. When things are quite simple, a computer can sort of almost read too much into it. We only ever use them as a tool, because if you put rubbish in, you get rubbish out.
I think there are more and more girls nowadays. At the end of the day, it's not just about their physical strength of what you can do, it's about here. If you have done your study, if you have built up your knowledge to carry out, an operation, doesn't matter what sex you are, you can just do the job just as well. I would say 80%, 90% of my time, I sit in the office. I do the design where I try to coordinate projects to make it happen. But then you also get the fun side of going on site and seeing what you have designed being built, and that's the most satisfying thing.
I think the key requirements are you need to like maths, but I think from a day-to-day point of view you need to be quite organised. We've obviously got a very tight programme for the construction programme. You need to make sure you get your work done on time, and be quite creative as well, so you try and find the right solution to a problem.
There's a lot of things that you have to concentrate on. You need to have good coordination with the architects, the contractors, and also you need to look after the client's interests as well. So juggling different things at the same time sometimes can be quite stressful. But at the end of the day, once it worked out, it's a fantastic feeling.
Yeah, it's extremely satisfying, definitely. I mean, just driving down the road the other day and we went past my first project. I was with my mates and I was like, oh yeah, I worked on that building. It's 26 stories, it's the highest one in this area. It's extremely satisfying and rewarding.
But it is satisfying when you're going down the road and you do see your finished product at the end, and it is a big old size. And also even going down to site is nice as well, just seeing 50-odd people working away on stuff you've done personally. There's very big employment prospects, there's always building going on, and even now there's not enough people going into it, so the opportunities are going to keep getting bigger.